Hi, so in this video lesson, we're going to be looking at projectile. And what is a projectile? Now, a projectile is an object or a body when launched into air and allowed to move on its own under the influence of gravity. So under gravity. So that's it. So when you launch a ball and it goes like this, boom. So it covers an horizontal distance and also covers a vertical distance. All right, let me give you a series of examples. Let me give you examples of projectile. So let's say that a short arrow, and you have somebody shooting an arrow like this, shooting an arrow like this. So how would the arrow go? The arrow will go like this. So you see that path at you. So it forms a parabolic path. So that path is what we call the trajectory. So that path at which the object follows is what we call the trajectory, and it has a parabolic path, parabolic shape. That's one, a short arrow. What about, let's see, a fired bullet from a gun? Let's see, a fired bullet from a gun. So the bullet is going to go like this and come down back. All right, let's see another example. This is the last one we're going to look at. A javelin. Somebody throwing a javelin. Okay, so javelin is going to go up, then also come down. So it covers a vertical distance, and also, so horizontal distance also covers a vertical distance. So that's how projectile is. So we're going to be looking at different cases of projectile. So I'm going to start with the first case of projectile, which I'm going to call the case 1. And how does that look like? Let's look at the case 1. And how does that look like? It looks like this. So that means an object is projected upwards in this direction. Okay, good. So that means it is projected with an initial velocity. Projected with an initial velocity. Let's call that u. Then, when it is projected, you see that it has an angle theta. It's projected at an angle from the horizontal. Now, and it does that, then it has a maximum height that it has to get, which is somewhere around here. So that's the height, maximum height. Then it also has a horizontal distance, which we call the range. That's the horizontal distance, the range. Okay, so these are very important parameters that we need to take note of in this kind of case. So when the object is projected from the ground level and it is going back to the ground level, this is the case 1. So let's see. Then let me list out the meaning of this parameter. U is actually the initial velocity or initial speed. Initial velocity / speed, as the case may be. Then you have the theta. The theta is called the angle of elevation. Let me call projection. Projection / elevation, depending on the words that I used. Then you have the h. The h is the maximum height. Maximum height. And then you have your r, which is called the range. And we can call the range, we can call that horizontal distance. So this is the horizontal distance. So from where it was projected down to where it landed. So that distance is the horizontal distance, or you can call it the range, and that's the height. And so we have three formulas to actually use when you are doing case 1. You have three formulas to actually use when you are doing your case 1. The first is when you are asked to calculate the time of flight. That means how long it took this object that is projected from the ground level to travel then down back to the ground. How long did it take it? So to calculate that time of flight, so that's capital T. It is the formula is given as 2u sine theta over g. Then if I have to calculate for maximum height, that means what's the maximum height? What's the maximum height that the ball will reach before returning down? So that's actually given as maximum height. Maximum height, which is h, is actually given as u squared sine squared theta over 2g. Then we have the third formula, which is the range. So the distance from here when it was launched to when it landed, the distance. So the formula is actually given as this. Range, which is capital R, is actually given as u squared sine 2 theta over g. So these are the formulas that you'll be needing to solve problems under the first case. And so in our next videos, we're going to be looking at examples on how to use these three formulas to actually solve case 1 problem.